Concept 4 is all about exponential and logarithmic equations. So here is how there are different types of equations. First of all, there's type 1, which is log equals log. And if you turn the page, there's type 2, which is log equals a number. And then if you turn the page again, we'll talk about exponential equations, okay? So there's a lot to cover in this unit, in this concept. So here we go. Here's how you solve these, all right? Step number 1, condense each logarithm using the properties we learned about before. Use the one-to-one property, which means if I have log base b of m equals log base b of n, meaning these two bases are the same, then all I have to do is set those equal to each other, then m equals n. Okay? Step number 3, solve and check for extraneous solutions. What this means is you need to check to make sure there are no negatives inside your logarithms. Okay, I cannot take the log of a negative number, which means that I cannot ask the question, what number to a certain power gives me a negative number, because it's not possible, okay? Excuse me, so extraneous solutions means no negatives. If you end up getting a negative, it doesn't work, and I'll show you how to check. Okay, so we're going to do the first 5 together, and then the last 5 we'll do in class. So 6, 7, 8, 9, and 10 we'll do together in class. So try them first. That's what it's always good to do, is try them on your own first. Struggle a little bit, and then come to class and ask me questions. Okay, so here we go. Number 1, log base 5 of 5x plus 9 equals log base 5 of 6x. Well, look at this. These are both log base 5, which means all I have to do to solve is set what's inside equal to each other. 5x plus 9 equals 6x. And now we have a simple little equation. Minus 5x, 9 equals x. Okay, solve and check for extraneous. So if we plug this back in, do we get any negatives? 5 times 9 is 45, plus 9 is 54. 54, nope, no negatives, so we're good. It works. So all you have to do to check is plug this back in for x and make sure you get no negatives. It's pretty simple. Okay. Log base 2 of 1 minus 4n equals log base 2 of 2n plus 43. These two are the same. So again, all I have to do is set these equal to each other. 1 minus 4n equals 2n plus 43. Okay, I'm going to subtract 43 and add 4n. So I get negative 42 equals 6n. Divide by 6. N equals negative 7. Okay, let's check to make sure there are no negatives. 1 minus 4 times negative 7. Well, negative 4 times negative 7 is 28, plus 1 is 29, so we're good there. 2 times negative 7 is 14, plus 43, or negative 14 plus 43 is still 29, so we are all good. That one works. Number 3, log 9, easy, set them equal to each other. Okay. Add 3w, 6 equals w. Now, let's check. Does it work? 6 minus 3 times 6 is 18. 6 minus 18 gives me negative 12. It does not work. This one has no solution because I got a negative. Okay. If at any point you get a negative in either one of these, it does not work. No solution. Okay. Number 4, we actually have to condense this log first before we get started. So this is a plus, they're both the same base, so I know I can make it into a product. 4 times y plus 5. Okay, now I have 2 logs with the same base, I just set these equal to each other. Okay, you can distribute. Subtract 20, I get 4y equals 52, divide by 4, y equals 13. Let's check. 13 plus 5 is 18. That's good, and that's the only place, so we're all good. Okay, number 5. This one I had to condense a little bit. I had to move this 3 up here, so this is actually log base 7 of 4 to the third power. Log base 7 of 4a minus 8. Well, 4 to the third power is 4 times 4 times 4, which is 64, and since these are the same, I'm just going to go 64 equals this guy. I'm going to add 8. 72 equals 4a. Divide by 4. A equals 18. Let's check. Well, 4 times 18 is way bigger than 8, so that's not going to result in a negative, so we're all good. Okay. Try the next 5 on your own. Come to class with questions, please. I want to answer your questions.